Okay, guys, so for 726, our whole goal is that we are going to use this kind of process of explore, conjecture, and then prove. So far, congruent triangles have helped to discover and prove many new facts about triangles and quadrilaterals. But what else can you discover? Today, we're going to work with about like kind of professional mathematicians, and we are going to explore, make a conjecture based on what we think, and then we're going to try and prove that conjecture or that guess. So the first thing we're going to do is we're going to look at the triangle midsegment theorem. So as Sergio was drawing shapes on his paper, he drew a line segment that connected the midpoints of two sides of a triangle. This is called the midsegment. So I'm going to underline that definition, that connected the midpoints of a triangle, and that's called a midsegment. So in other words, D is in the middle from C to A, and E is in the middle from C to B. And what he did was he connected those two midpoints right there, okay? And he said, I wonder what we can find out about this midsegment. So the first thing we're going to do is we're going to explore. Examine the diagram of triangle ABC drawn to the scale above. How do you think DE is related to AB? How do you think their lengths seem to be related? So you can go ahead and pause this video and you can think about how DE is related to AB. So think about how the green line is related to this orange line. Okay? After you've paused this video and you made your guess as to how they're related, I'm just going to cut the green line out and show you guys. If you take a look at that. Do you see how the green line will fit twice inside the orange line? Okay, so I'm thinking in terms of right here where it says how are they related, how are their lengths seem to be related. I would say it looks like DE is half of AB. We can also look at this like if I take two DEs, it's the same thing as AB, okay? Excuse my dog, he's chewing on a bone right next to me. So again, two of the green lines are equal to one of the orange. So that's the conjecture that I'm assuming most people went ahead and guessed. And again, take a look at this. Two of the greens equal one of the oranges. Or you can say that half of the orange is equal to a green. Okay, those are the same things. So it says write a conjecture about their relationship. So to me, that's also the conjecture. I just went more into depth as to how those are related to each other. So I would write the same thing as that's my conjecture. That's my guess as to what I think is happening. And now it says Sergio wants to prove that AB is equal to 2 of DE. However, he does not see any congruent triangles in the diagram. How are the triangles in this diagram related? So they're not congruent to each other. I am going to say that these triangles are similar. Okay, and the triangles that they are referring to, if you look back up at the top, is this the tip of the triangle right at the top? And I'm going to cut it out really quick right here. Copy and paste. Okay, so I'm specifically looking at this top triangle in relationship to that larger triangle right there. So I'm saying that this smaller triangle, CDE, is similar to, okay, that bigger triangle of CAB. Sorry. It says, how do you know, and then prove using a flowchart. Okay, so let's start with our flowchart. I want to, again, prove that these triangles are similar. There are 3 ways that we learn to prove triangles similar. It is by angle-angle similarity, side-side-side similarity, and side-angle-side similarity. So the first thing I'm looking at is I'm going to take a look to see if I have any angles that I know for sure are congruent to each other. And I do see that angle C, and I'll mark it in the larger triangle, is equal to angle C in the smaller triangle. So I'm going to write that down as my piece of information. Angle C is congruent to angle C. And I knew that because they're the same angle. It's also called the reflexive property. Okay, so I have a pair of angles. I don't have any other angles. They did not tell me that the lines are parallel to each other, so I don't know if corresponding angles are congruent to each other, but I do see some tick marks. So on my pink sides, it looks like one of these pink tick marks and two of these pink tick marks. So if I look at the actual ratio, it's a 1-to-2 ratio. I'm going to do the same thing for the blue sides. Again, okay, I have one side with two tick marks, and here I have two sides with two tick marks. Again, that's a 1-to-2 ratio. In other words, I have to take the smaller blue side and multiply it by 2 to get to the larger blue side, and I have to take the smaller pink side and multiply it by 2 to get the larger pink side. Okay, that means that the scale factor is the same, meaning that I have two pairs of sides that are proportionate. Therefore, I'm going to say that this is side angle side similarity. Now I have to continue to write what I know. So again, I know that the proportion of CD over CA is equal to CE over CB. And I know that proportion again is equal to 1/2. If you'd like to also write that as well. And again, we showed that very clearly up there. So with this information, we can now say that the triangles are similar to each other. Now again, this is just a flow proof. So we're just flowing on through. So I can say that CDE, the smaller triangle, is similar to CAB. And the reason that I said that they were similar is because of side angle side similarity, okay? The reason that I wanted to do that, and we want to take this a step further, is because we're proving our conjecture. Because these triangles are similar, that third side that we haven't spoken about, so this bottom green side and this bottom orange side, again, because the scale factor is 2, to get from the green side to the orange side, you need 2 greens to make that orange. In other words, you need 2 DEs to make an AB. Okay, and the reason is right here. Because these triangles are similar and have a scale factor of 2, that means that DE over AB also has to have the same ratio of 1-to-2. Okay, once the triangles are similar, all the sides are proportionate. Sides proportionate when triangles are similar. So because those triangles are similar, those sides have to be proportionate. So it says, what's the common ratio between the side lengths? And the ratio is 1-to-2. Okay. You can also say the scale factor is 2 if you'd like to do that. And it says use this to write a statement relating the lengths, and we already did. We said that DE was equal to half of AB. You can also say that 2 of DE is equal to AB. Okay, these are the same statement, just written a little bit differently. So if I, again, multiplied the top by 2, it would get me to the bottom equation. Okay, so first I made a guess. Okay, then I proved my guess using my flow proof. Okay, so again, explore, conjecture, and prove. The next thing is Sergio wants to prove that DE is now parallel to AB. Use the similar triangles to find the pairs of equal angles, and then we're going to prove that it's parallel. So we proved that these triangles were similar to each other. because the triangles are similar, the angles are congruent. In other words, this red angle is equal to this yellow angle. And if those two angles are equal to each other, they're corresponding. So if corresponding angles are congruent, then the lines have to be parallel. And what we just proved is that this green line is parallel to this orange line. So what I would do if I were you guys is I would go to your cheat sheets now. And in your cheat sheet, I would add what's called the midsegment. Okay? I would put down what the definition is. And if you guys remember here, I'll do it right here. So the definition of a midsegment is if you take any triangle in the world, so maybe draw some sort of obscure triangle, if you were to connect the midpoints, so again, let me take this pink side and I'm going to put down its midpoint. So here's its midpoint. And if I was to connect that midpoint to the midpoint of an opposite side, so let's find this midpoint, which appears to be right about here. If I was to connect those two, there we go, that segment that I just drew is half as large as the third side of the triangle, and it's also parallel. So again, a midsegment is created by connecting the two midpoints of a triangle, and that midsegment is half as big as the third side, okay, and it's also parallel. So again, midsegment, connect midpoints of triangle. Okay, so again, we show they're the midpoints by putting tick marks. Okay, so that's the definition. A midsegment is connecting the midpoints of the triangle, and the midsegment is half as large as the third side and parallel to the third side. Okay, and there are three midsegments in a triangle. So again, this green side also has a midpoint. Okay, and I can connect the pink midpoint to the green midpoint, and I can connect the blue midpoint to the green midpoint. Okay, and again, the relationship between these, the pink sides are parallel, and the smaller pink one is half as big as the larger pink one. The green ones are parallel, and the smaller green one is half as big, and the blue ones are parallel, and again, half as big. And these are created by, again, connecting the midsegments. Okay. And then 7.104 just brings up that explore, conjecture, and prove. The next thing is a right trapezoid. Okay. So a right trapezoid is a trapezoid that has two right angles. Okay. And again, if this is something you want to draw on your cheat sheet, you absolutely can. I'm going to skip this one, and I'm going to go down to, okay, this isosceles trapezoid. So an isosceles trapezoid is a trapezoid with a pair of congruent base angles. So that's the definition of an isosceles trapezoid. So again, it is a trapezoid which has one pair of parallel sides that has congruent base angles. So it says, what can you learn about the sides of an isosceles trapezoid? Examine it below. How do the non-parallel sides appear to be related? So if we take a look at this, how do these sides appear to be related? And they appear to be congruent or equal to each other. Okay. And then it says to write a conjecture and to prove your conjecture using the Midsegment theorem. And they use that whole explore, prove, conjecture kind of thing. I'm just going to basically tell you guys this is the definition. So just like an isosceles triangle, if you have an isosceles triangle, my voice is going. if you have an isosceles triangle and you remember the base angles are congruent, the sides are also congruent because an isosceles triangle can be folded so that the left side and the right side are the same. The same holds true for an isosceles trapezoid. You can actually fold it in half. The sides will match up, so the right side and the left side will match up to each other. I can't talk much longer. But I would make sure that you also have an isosceles trapezoid drawn on your cheat sheet, and that you have the tick marks on the left side and the right side, and the tick marks for what's called the base angles as well. Okay? But just this idea of explore, conjecture, and prove. Okay? Going back up. Boop, boop, boop. Here we go. And then that idea of midsegment, making sure you guys have a midsegment drawn on your cheat sheet. Okay, and that's the basis of 7 to 6.